Sure.
Good afternoon to Mr. Yang Kwan, co-founder of Kiwi Technology Incorporation. Distinguished delegates, ladies and gentlemen, welcome to the third key speaker session of 2017 International Youth Leadership Summit on Artificial Intelligence, Era of Exponentialism. Artificial intelligence, or abbreviated AI, in short is intelligence exhibited by machines. In computer science, an intelligent machine perceives its environment and takes action that increases its probability of success at some goal. Simultaneously, the term artificial intelligence is applied when a machine mimics cognitive functions of a human mind, such as learning and problem solving. In the 21st century, AI techniques have experienced a resurgence following concurrent advances in computer power and the ever-expanding Internet of Things. Recent advancements in AI have contributed to the growth of autonomous things, such as drones, self-driving cars, and facial recognition applications, becoming the main driver of innovation and service-oriented daily lifestyle. Today, the organizing committee of International Youth Leadership Summit is pleased to have Mr. Yang Kwan, co-founder of Kiwi Technology Incorporation, as our honorable guest speaker. Kiwi Technology Incorporation is a Chinese technology and graphics company that specializes in providing consumer products and building 3D graphics and visual effects. Kiwi has developed Camera in 2016, a mobile camera app that creates 3D virtual reality effects on faces, similar to Snapchat lenses, and is currently available on Apple App Store and Android Play Store. In addition, Kiwi licenses its AI product Kiwi Face SDK to over a dozen mobile video and live streaming apps, including Flurry Live, Blood, and Livestar. By building strategic partnership with cloud service platforms like Agora and Chino, Kiwi is reaching over 1 billion audience network. With that, I hereby invite Mr. Yang Kwan to the podium to present his talk on artificial intelligence.
Hey guys, how's it going? Where's my PPT? I get nervous without PPT, so let's do it. So first I want to apologize that some of the content may be in Chinese, but last night I changed all the titles of each slide to English. So if you don't read Chinese, you get a rough idea, but I would say that 99% of people won't read the text on the PPT, they just read the photos. So we should be fine. You control it? Okay. So about Kiwi, so next. So what is Kiwi, right? So lots of people say, you guys from New Zealand or what? We're actually not, we're from China. So either it's a fruit or it's the Kiwi bird, which is the national bird of New Zealand. So because a lot of people say this, we actually changed one of the apps to this kind of logo. So combine the face with the Kiwi fruit together. But again, we're not from New Zealand. That's our name. It's a very short name. It's very powerful, short, easy to understand. This is our team. So our CEO and me, we both graduated from UC Berkeley. He got a degree in math and computer science, and after which he worked at Microsoft in Seattle for almost 2 years. And also after Microsoft, he worked at LinkedIn. And then he started his first startup in a social app called Sober. And this project is his second startup. So I met him in 2009 at UC Berkeley. And I graduated with a degree in financial engineering. So it's a master's degree. And after I graduated, I worked at Moody's Analytics in San Francisco and in Hong Kong for 3 years in total. So what I did back at the time was to create some financial models for credit analysis for the portfolios. So there was a lot of programming, mathematics, and statistics involved. And right now, I'm in company to do lots of operations, and, as the CEO. And another guy of ours, he's basically doing the MIT PhD program in computer science. And his field is basically machine learning, deep learning, artificial intelligence. So help us do a lot of research analysis. And he used to work at Google for the AdSense team. And he also graduated from UC Berkeley. That's how we know each other. And we also have a professor, Liu, from Nanjing Information Engineering University. He is very famous at computer vision. So if you know computer vision, there's a very famous ImageNet. So basically, lots of rankings on computer vision are published on ImageNet. So he actually will rank #1 in the world in multiple fields. Our team has 25 people in total, including this handsome guy over here. And the ratio of male to females is horrible. So if you're a girl, you want to join us, please let me know. You can see all the girls out here. Half of our people are engineers, so very engineering and research heavy team. And we have several designers and several business people. So that's us, right? What we do, our technology is 2 areas, so AR and AI. So we both focus on the human face because we think face is very important. It's basically a lot of people know each other by face. And it's the most powerful image of ourselves. So the AR, the augmented reality.
Touchscreen.
Oh, it's touchscreen. Did I touch it? All right. I'll be careful. Just getting too excited. So AR is basically adding the virtual object onto your real face in real time. We achieve this in a mobile field. We're going to break this down and talk about each area in detail. The AI is very big. It's a broad topic, but we're focusing on the facial recognition part of artificial intelligence. So through the machine, we can actually know who you are just with the camera. And we use deep learning to achieve this. I'm going to talk more about this later. So let's get into some hard stuff, some core stuff. Let's begin with AR. Who doesn't know AR? It's okay if you raise your hand if you don't know it. Okay. So basically, I tell you one experience. So I was in Silicon Valley this 2 months ago in May. I was there for a conference. So when I passed the immigration, I still need a visa to pass through immigration. The officer just stopped me at random. Because I carry a lot of stuff for the exhibition, right? Carry a lot of bags. So he's very suspicious. Like, this guy carries so many things. Why do you come to America? He's like, hey, why do you come here? I'm like, I'm here to attend a conference. What conference? A conference in augmented reality. He's like, what's augmented reality? Right? So I really think hard how to explain this to him. I was like, have you watched a movie like Harry Potter? He's like, oh yeah. I said, do you remember on the movie, like if you walk by the wall, there's actually a portrait. But if you look at the portrait, actually the face moves, right? I can talk to you. That's kind of the idea. It's like something is there, but it can interact, the virtual world can interact with you in real time. And the ability to add the virtual interaction onto the real world. That's augmented reality. So that's how I explained to him. I'm not sure whether he understood. He just like, okay, just go, whatever. But I don't know. Just put it out there. So AR, so we can break it down to different horizons. So first, I want to say that if you look at time as a vertical, the evolution of technology starts with the personal computer. I'm talking about the information evolution. So this one starts around the 1980s. Let's say 1987. That's personal computer. And then we go to the internet era, right? 1997, 10 years later, we go to the internet era. And then again, 10 years later, we go to the mobile era, like 2017 when the iPhone was released, right? Lots of tractions going on to the mobile world. And then again, 10 years later, now we're in 2017, and then people start to talk about VR, the virtual reality, AR, and MR, mixed reality. So this is kind of the time vertical. in general. And last year, 2016, was publicly recognized as the starting year of VR. But last year, when you listen to the news, talk to people, not too many people talk about AR, right? So lots of people are talking about VR. We put on the headset, you can actually be detached to the real world. You can see any virtual object. But at the second half of 2016, you start to hear people talk about augmented reality, right? Not just a completely different virtual world, but the ability to add on the real world. And then 2017, the AR started to become more and more of a topic. Lots of people saying AR is going to be bigger than VR in the future because we can't be completely detached from reality. There has to be something for the reality right now. So MR is basically a very close term to AR. The mixed reality means I'm able to add a virtual object. I'm able to recognize where the floor and where the ceilings are. And based on those information, I can virtually put the object there. If you watch the Microsoft HoloLens introduction video, you'll know what MR is. So all these three terms can be summarized. Sorry, touch it again. All these three terms can be summarized as XR. Right? So X is basically if you study mathematics, a variable that can be replaced by a V or A or N. Right? So all this can be called XR. So this is kind of the time horizon we're at right now. Next. And if you look at the landscape as horizontal, so if you break it down from here, this is the AR landscape. A lot of companies are doing AR effort in different areas, applications, tools, devices, input. I have no time to go through each of them, right? I don't think you wish me to do that. So we're gonna go to the next slide to look at some of the big players, like what they do. Can anyone tell us like which what this one is? Nobody? Just give it a shot. I don't have a gift, by the way. You can just give it a shot. This one is actually the mixed reality. This is the HoloLens. So basically, this Microsoft company, they released a device which is very expensive, like $3,000. You can wear that device. So through that device, it's a transparent, basically a lens through which you can see the virtual, let's say, note on your refrigerator, the virtual photos, virtual video player on your wall. This is mixed reality. So this is basically Microsoft. This is Snapchat. Right? Lots of people use that Snapchat. So Snapchat acquired a company called Luxury in 2013. So Luxury is a company that first realized the virtual object on mobile. Right? So this is using a device. This is on mobile. So Snapchat acquired Luxury and it basically improved its model. Now being known as the Snapchat lenses. This is Google. So Google, what they do is they released a project called Project Tango. So Project Tango is a phone that has a depth camera, is able to know the distance, let's say from here to the wall. And then through that screen of the phone, it's able to put virtual object on the screen. That's Google Tango. By the way, I have a Tango phone with me right now, so if you want to experience that, you're welcome to try that. I might just gonna pass it around for those who haven't tried this. Has anyone tried the Tango before? The Tango phone? This is basically Google's approach. So the idea I want to give you is different big players approach the AR in a different way. They have a different kind of way of thinking. Let me just finish this slide first, and we'll pass it around. This is Facebook, right? So if you're watching me on Facebook, this year, in April, they released a AR Studio. So AR Studio is basically, if you know, like Facebook is competing with Snapchat in a lot of ways, right? It's kind of the social layer. So through this AR Studio, the designers are able to design their own AR object through this platform. And after that, the designer can publish its design on Facebook camera. So that's AR Studio. That's what they do. And Zuckerberg firmly believe like AR is going to be the next computational platform. So this is Facebook in this year, 2017 April. This is Apple. So Apple released AR Kit with their iOS 11, and it's going to come with, I think iPhone 8 it's going to have a depth camera. Right? A lot of people say that. So with the AR Kit, you're able to develop your own apps in AR. For example, I can develop an app that measures the distance from here to the end of this room, right, using AR Kit. I can develop an app that places, let's say, a tank here on the mouth, and then it moves, and when I move my iPad or something, it's going to stay there. And I can develop an app for games. So lots of tractions after the AR Kit was published. So Apple got this technology from acquiring a company called Mattel, right, back in the time. So this is basically what the big players are doing. So you can see different approaches here, right? Let me summarize all this stuff. So Microsoft is thinking about, okay, I can build a hardware that is wearable on my head, through which you can see augmented reality, virtual reality. Snapchat and Facebook are thinking, okay, I think everyone has a cell phone. So why don't I just upgrade the cell phone right now? Like, I can use my phone to show the AR effect. Google is thinking, your cell phone right now is not good enough. Let me put this depth camera on your cell phone so that it has better AR effect, right? Apple is thinking, okay, I'm gonna have this AR kit similar to those, not just for the faces, but also for other objects. I can have this AR development tool for everyone to develop the AR content. So right now, I'm just gonna pass this around, and you guys can just check it out. This is Google, by the way. Work with Lenovo. Let me just show one thing. I'm not sure if this one can connect to the screen, so you guys just can see yourself. And I'm gonna have this. You can just look at it around. It has like a virtual object real time, like a virtual dot. And you can just pass it around. or let's say you can change this one to, maybe this is more. So first it has to recognize a circus. Yes. Let's say this is a circus. Okay, you can see the flowers all around. You can just pass it around to people. Let's see. So I hope like by giving this lecture, yeah. So what I hope by giving this lecture is I'm not just gonna, be selfishly talking about our firms, but also give you guys a little bit, broad view of what's going on in the industry. That's the end of industry introduction. This is Kiwi. So what we do, a lot of people you may realize, a little bit similar to Snapchat, we have these virtual lenses on your head. I'm gonna play this video to show you our models. This is it. Enjoy. It's Stephen Curry made for the League Finals. This one a little bit laggy, but the reality is not laggy at all. It's probably something to do with the system. Alright, so you can download this on the App Store. We have iOS. Android is coming up. So if you use iPhone, you can scan and download. This is our app. I'm just going to take this from you. Edison, do you mind? Okay. Okay, cool. So, not just we publish our own app, we also enable other people to use our technology by giving out SDK. So we democratize this AR facial effect by giving them stickers, virtual stickers, the beautifications like eye magnifying or like chain slimming or whatever. Like lots of girls need this, right? Maybe guys need it too, but lots of girls need it. Animations, this 3D avatar, and and then change the background real time. So you're gonna recognize the outline of your figure and change the background. So these are all the features you can get from using the SDK. And we beat our competitors because we have not just have features, but our efficiencies are better. I'm not sure why this looks a little bit weird. But this is kind of a comparison. this is a comparison of ours versus the competitors. So we basically are more smooth. We run like faster on low-end Android phones. This is the CPU and RAM usage breakdown. So our usage is lower than the competitors here. Do you have any questions? You can just let me know. So this is SDK. So to summarize, we serve I think around 15 or 20 customers. So the customers are the video chat apps, the live broadcasting apps. You know, China people like to live broadcast themselves.
Yep.
So, what's that? Yeah. do you watch a lot of videos? So this is one kind of scenario where like an app using our technology, so having the virtual airs, and then this is our customers and our partnership, like we mentioned, the Agora and Qinyo and Huanxin. So those companies are the live streaming companies. So they integrated the official SDK as part of their solution. So we're not just staying with AR completely. We also one of the companies in the HTC Vive accelerator program. So if you know Vive, HTC Vive, it's a VR headset. So because VR is so new, so they want to create this ecosystem where they invite a lot of companies to develop content, develop add-ons to provide. So we're part of that, and we just finished our accelerator program last month. So this is what we do in the accelerator program. So basically, we made this AR technology into a little bit like a VR. What I mean by that is you can see this video here. See, like my face, this is me, by the way. So my face will change to a different face in real time and split into two views with a different angle. So once you put on the VR headset, you're able to see me in VR with a different face. Right? So let's say you're not satisfied with your boyfriend or girlfriend's face, you can swap it with any celebrity. But you just have to wear that awkward device in real time. That's it. So, did I go really fast? I still have 40 minutes to go. I'll talk a bit slower, but if you have questions here, let me know, right? I don't want you to stack all your questions at the end because you may forget some of the content I talk about. So you can just interrupt me at all times. So that's the end of AR, right? And then we're going to talk about AI, the artificial intelligence. So first, this concept of deep learning. So artificial intelligence is a very broad term. It includes a lot of different sub-areas. For example, like machine learning is part of artificial intelligence. Deep learning is part of machine learning. But what really got on fire this year is the technology of deep learning. So deep learning is made available through two advancements. One is our hardwares. The cost of computation is getting lower. So everyone knows like Moore's law, right? The cost of computation is getting faster and faster at exponential rate. So right now we have this GPUs, the graphic processing unit, that is very cheap and is able to process a lot of computations. So first is our hardware made it available for us to process a lot of data in real time. And second is we have an ever-growing amount of data available. So with the big data and the low cost of hardware, the deep learning is available by using a neural network, structure. So the neural network is based on these two advancements. So why we choose deep learning? Why a lot of people like this is that as the amount of data grows, the performance of the model is getting increasingly better with deep learning. So this is the older learning models. This is deep learning. So deep learning is proved to outperform a lot of traditional machine learning models. So that's why a lot of people using this, and it's really got on fire this years. So give you a little bit very high-level introduction of how deep learning works. So this is what you see as a neural network. So people get this idea from studying, people's brain, how the brain works. The brain has like trillions of different neurons. And each neuron is connected to a neuron in the next layer. And the information passes through from a neuron to the next and to its adjacent neurons and so on. So we're going to imitate how the brain works in a computer program. If you think about how people recognize, let's say, how do people recognize a face? How do I know who she is? If you think about this, people actually break it down to different parts. So I can say that, okay, her eyes look like one of my friends, or like her mouth look like another celebrity. We can break it down to different parts of the face. So this is similar to how deep learning works. First, it's going to scan this photo, and then it's going to retrieve this information. So because, let's say the eyebrows is made of lines or like circles, the curves, it's going to retrieve this little element in the first step. And then the second step is going to combine this kind of little elements together to form different, let's say, organs, like the eye or the nose. And then we're going to put it together to form a face. So this is very similar to how humans recognize the object. We break it down to small parts, we put it together, and then in the end, it's going to know who this person is, because a similar person may have a slightly different nose, but a very similar face, but still it's a different person. Right? So this is how deep learning works. But in order to achieve this, it's going to use a lot of data to train the weights between the neurons. How do I know the weights are? I know this person, I know the results. I train this model over and over again to adjust each weight in between the neurons. And over time, if I have a lot of data, millions of faces, I can twist the weights in a way that it's going to recognize 99% of the people. Right? So that's how deep learning works in a nutshell. Getting sleepy or what? Okay. So this is our deep learning model. It's called Kiwi Face X. And we achieve an accuracy rate of 99.7%. And this is the example, like Michael Jackson before and after. We still recognize him as the same person, right? So as a human face, you can tell, it's very hard to tell, but because it maintains like certain organ and certain ratios, the machine is able to tell it's the same person. And so in comparison, our accuracy rate is in par with Tencent, with Baidu, Fizz++. So we're basically among the top performing models. And you can actually, test yourself here by going to this link. So this is how we perform. If you study the area of facial recognition, you're going to know this LFW is short for label face for the wild. So this is a data set that you can test your models upon. So this is our performance here. And the different verticals, this is the false positive rate. This is the true positive rate. So what I want is, I want the true positives as high as possible and the false positive as low as possible. For example, the true positive is like, if I can recognize me as the same person, if I, let's say, have a different hairstyle or wear a glass or not, it's true positive. False positive is, if there's two different persons, it should tell me it's different people rather than the same people. So there's a trade-off between the two. So I want this to be as high as possible, and the false positive to be as low as possible. And then our curve is actually above a lot of competitors. So you want this to be further to the left-hand side. So on this range is very commonly used range for false positive. 10 to the power negative 3 means that I can accept there is one error within 1,000 people. So if I do 1,000 people comparison, if there's one error, I can accept that, right? So between this 10 to negative 3 to 10 to the power negative 4 is the most common usage of the range. So within this range, our true positive rate is actually above the competitors. So the functions here, so not just we can recognize the face, we can detect how many faces in a photo, right? You can put a camera on the, on the building or whatever in your restaurant. You can count how many customers going to your restaurant. It's able to recognize the gender, the age, can guess the age, I would say, can guess the emotions, the facial expressions, and also you cannot cheat by printing out a photo, right? Because a photo cannot move its eyebrows or mouth, so we can detect a live face real time. Right? Any questions or you guys are all?
Do you use this app in some mobile phones? It's a simple app, like in different companies like Sony and other mobile camera. They also have this kind of feature.
Yeah.
So you are using this feature as a separate app, or it is integrated with some camera?
I'm going to talk about the usage later, but this algorithm isn't run on mobile. It's run on the server because the mobile doesn't have enough computation power to run this. If you put on a mobile, the accuracy rate is going to drop. So what we do is we use a mobile camera. We capture I'm going to show you a demo later. We capture the photo. We send it to the backend server. It recognizes the face and give it back to the result. So that's
because I have used this feature in Xiaomi.
Yeah,
and it was a bad experience because sometimes it recognized me as a female.
Sometimes. What are the times you're recognizing people? Sometimes. Maybe it has said something. That's good. Xiaomi, okay. So, but it runs on the mobile.
Yeah, on mobile.
Because run on mobile, you're going to suffer from the performance. That's why you have lower accuracy rate.
I don't know why.
It's very hard to achieve 99%.
As I have a beard.
Okay.
Did Xiaomi they will use a Russian?
Does it recognize your nationality too? Okay.
Yeah.
But it's awesome.
You mentioned that actually I am working on the probability. How much probability is there right and wrong?
Yes.
So how you can the most difficult on this kind of software is kind of actual giving actual numbers giving suppose that age.
Yeah.
Suppose the age.
Yeah.
So if I go like that, is different age and little different.
Yes.
Lower.
Yes.
So when you make a software, so when you put the data on there, so you have to which method you should notice to have this much age because of the color, skin tone, brightness, blood flow.
Yeah, it does. It has the effect. Yeah.
Something else.
Yeah.
What you took on the basic fundamental on there.
Yeah. So you're asking about the age, right?
Yeah. Suppose it is.
Yeah. So this one we just use a lot of data. So for example,
a lot of data.
you're 20 years old, and amount of people of age 20 years old can be dark face or bright face or different stuff. So it's going to capture all that.
So you're going to capture all pictures. So that pictures capturing the pictures have a what unit what kind of unit you can figure out there a glowing face. Suppose that I put a very good cream and it's look like
yes. It's going to have an effect. Yes.
Not the cream even. If I go and do a jogging and after come back I will
it's not very accurate.
Yeah. And that is very difficult to recognize the face.
Right. So if you shave your beard, you might appear.
Of course, it's different.
Different.
It's so what you
it needs time to grow the beard.
Yeah. So what you use on that? Which unit you use to recognize the face, blood flow.
So that's I cannot tell you a single element, but it has all different things put together, including the distance between, let's say, your eyes, whatever. Make it older, you can change your feature in a way. But I cannot point out a single element that is the most important.
No, at least which kind of unit, what kind of, you said, combining all this screenness, facial expression. But it
doesn't matter. So when you train a model, the input image is going to have all different angles, different facial expressions, different like makeups. But I know the age of each input image, so I can train my model in a way that captures all that.
So
but it's not accurate. It's not.
So that's not accurate then. Probability will be not true. I mean, like even 60, even 80% correct.
I don't know exactly how accurate this age like estimation is. The 99.7 is a different measure, but I know what you're saying is like a lot of apps that I see can tell your age, like Xiaomi phone, right?
No, forget about the Xiaomi. If you use your software, your like whatever device you have, your device also have this kind of drawback.
Yeah.
Because,
yeah, it's gonna change. Yeah. Yeah, it does.
So like because if you know the fundamental, like what is the unit behind that, like the heat, flow, whatever things. So if you use like a few days like the heat measurement. If you will have a different heat measurement on that basis, you can know the age. And if somebody will angry, then somebody is happy, then you can different the facial expression, and that's make a
Yeah, I know what you're saying. So you can basically categorize different facial expression, for example, as a control group, like a fixed effect, right? You can just leave out the fixed effect. I don't know about that because I'm not sure how that works on top of deep learning model. That's actually a very traditional way of creating a machine learning model. So I'm not sure how these two can combine together, but I think it's a good thought. I can't answer right now, to be honest. I don't know. Maybe it can work better, like what you said. But a lot of uses, like, let's say, change your face age real fast, you can take like a moving average of your face within the last second or something. But honestly, it's not very accurate because the computer doesn't take more information than this image. So even human eyes can be deceived. Let's say if you put on a cream, you appear younger, right? Even the human eyes can tell your real age, unless I know you in person. So, but it's a good question. It's a good question.
So what you're saying is when you let the machine do deep learning, basically you just give them a lot of inputs and then you tweak the output. So then the machine can compare with the past data that this is probably 24 and this is like 25 years old based on past data.
So there's two steps, right? So one is train the model. So when you said was, I put a lot of image here as input. I don't tweak the output. I know the output. I know who you are. So basically, this is the fixed result. I tweak all the weights in between, so that the accuracy is higher. So after training, training takes a lot of data, takes a lot of hardware to train. After training, you run the model. It doesn't take as much hardware because you don't take a lot of input data. You only take one image. Let's say if I run a model, I want to see who you are. I just put your image here. It's gonna predict a result. Right? That's how general model works. Not just deep learning model, but all like machine learning works in the steps.
On 1 minute, can you have over? Actually, I'm thinking like that. If you can do like this way, like you know the retina, the eye's retina cannot change by the age.
Yes.
It's lifelong.
Yes.
So if you make this like your server working on the server, so you put it like a number of eyes, like when the person buy a computer, person buy a mobile.
Yeah.
They can store his retina images.
Yeah.
And then you can know the actual time what is the age. And then when retina is already detected and retina goes to that data goes to in server. So when the person will come on there and that data, the retina matches to that person retina, then they give actual age. So that is number of chances is very rare to get the wrong information, like to give the wrong information about the age.
Yeah. So you raise a different topic. It's like the biorecognition field has different focus. So one is you can use face, you can use retina, you can use your palm, you can use your finger. You know, every approach has pros and cons. Right? So for retina is more accurate. You know, your retina doesn't change. Like when you're born as a baby versus now, it's the same. But in order to detect that, you need a special device, and then you have a distance error problem. Right? Let's say the facial recognition, I can basically recognize my face like 2 meters away, but with retina, you have to walk really close. So there's different use cases and pros and cons of each. But we're focusing on the facial part first. Yeah, I appreciate your question, but I think you helped me kill a lot of time. So I'm just hope to rush up a little bit, and I'm gonna save more. I mean, you can still ask questions, but we're gonna save more questions for later on, right? I realize this has a lot of slides. So the model is robust on different scenarios, so different angles, different like distances, age, and also different makeups. It's going to recognize the same person. So the application of this includes one of them is the smart gate system. You go to a train station, you go back to your apartment, it's going to scan your face. I think a lot of the offices have this right now. Some companies doing this, like Face++ or SenseTime. You have this scan face, checking your office. And we're partnering with, because we're based in Nanjing, we're partnering with some local businesses. For example, this is one on the retail store. So what they do, this is actually from Seattle. So what they do is, under every product, they put an iPad. So on the iPad, it's going to display the information for the product, but also through the iPad camera, it's going to read the customers, right? So who is watching this, how long time, how many people are passing by, is a male or female, like old or young. They want to get all this big data from a retail store. So they want us to provide this backend technologies for them, like a smart retail store, like big data kind of idea. So AR and AR put together, right? We walk through each of them and we put it together. So our roadmap is we have the AR SDK, we have facial recognition. We're gonna combine this together, and we raise a concept called smart AR. So if you think about AR as computer graphics means the computer is gonna render, it's gonna display information on top of the real world. The AI is computer vision, means the computer is reading information from the real world. So there's two different directions. So this is write, this is read. So the smart AR actually means I write based on what I read, right? So I use facial recognition to know who this person is, and based on that person, I'm gonna display an AR effect that the person likes. This is the simple explanation of smart AR that what we're trying to do. So the smart AR has a lot of use case. So one of them is actually the advertisement. So right now, the advertisement screen has a lot of problems. For example, it doesn't recognize who you are. Like when I don't know, like my building has a lot of advertisement on like, plastic surgery and all stuff. It doesn't relate to me. So if it's able to, maybe it does, but I didn't do that. So if it knows who I am and what I care, it can display information based on my preferences. So this is the smart AR screen we're trying to make. So it has two areas. One is AR effect. It's gonna give you the virtual try-on in real time. And then it can recognize your face and retrieve the big data information like the age, like the emotions, gender. So we can achieve this by simply adding a camera on the current end machine. That's it. Through one single camera, it knows your face. This is my partner. He looks very tired, but I'm still gonna play his face. This is Snapchat, by the way. We just stole their advertising, but just to show you the concept. So this is a movie advertising, like AR movie. At the same time, it's gonna get the data, right? So I think before that, let me give you like a little demo here on what I mean by this. So this iPad is connected to the internet. So this one has both AR and AI together. So what I mean by this is, suppose this is my face, and I'm wearing some virtual stuff. Can you guys see this? Can you see this? It should. Wait, let me. 那个 server 是不是大？怎么感觉不行？应该是可以自动。 it should able to recognize my face, automatically change. Why it doesn't work right now? Okay, let me give the server a little bit of rest time. Maybe we'll demo later on. It should recognize my face. 你要问下他们的重启啊 server， 刚还可以，刚那个讲之前那个。Yeah, we're gonna give you a demo later, or you know after this talk, you can come here